Last section for the chapter, absolute value. Absolute value equations and absolute value inequalities are both covered in this section. They were two separate sections, might have even been two separate chapters in Algebra 1. But here they are both right now. Absolute value is actually a distance. What do I mean by that? What is absolute value measuring if it's a distance? Distance from zero, that's right. So if I were to say our symbol, absolute value of x, so let me just do an example, absolute value of -4. What that means is how far away from 0 is -4. So if I put a number line down here and I put 0 right in the middle, which we don't normally do, and then I graph -4, it would be right there. So how far away from 0 is it? That's its absolute value. This distance right here is the absolute value of -4. And distance is always positive. So the answer here, a distance of how much? 4. What if I had the absolute value of +4? Now I'm over here 4 units. I'm still looking for the distance from 4 to 0. What do I get? 4. It's 4 units away from 0, no matter which side of the number line you're on. For -4, it's 4. For +4, it's 4. 4 units away. That's all absolute value is. We use these symbols to denote absolute value. That's pretty much all I have to say about the review of what absolute value is. All right, solve and graph, then check. And what's probably the most important thing up here? Always check. You have to check your answers with absolute value. You don't have a choice. Because sometimes you might get something that's called an extraneous solution, a solution that does not work. That's a vocab word for this chapter, by the way, right? Yes. Solution that doesn't work is an extraneous solution. So you have to check your answers here. The way that you do this is you say, if I take the absolute value of something, and it winds up being exactly 5 units away from 0, then I could be 5 units away on the left side, or I could be 5 units away on the right side, which means I have to account for both cases. So I have to split this problem into two separate problems. The case where it's on the left side, so 2x minus 1 is equal to, let's do the case on the right side first, or 2x minus 1 is equal to the other side, -5. You don't need the or there. Let's get rid of the or, that's bad. Let's do case 1 and case 2. Remember that from Algebra 1? Split it into case 1 and case 2 for absolute value. And now once you split it up, you just solve it as two separate equations. So we add 1 to both sides, and we have 2x equals 6. So divide by 2, and you get x equals 3. Over here, add 1 to both sides, and you get 2x equals -4. Divide both sides by 2, and you get x equals -2. Two answers. What do we need to do now? You always check. It doesn't take long. Take the 3, plug it in. 2 times 3 is 6. 6 minus 1 is 5. The absolute value of 5 is 5. So this one works. I'm going to circle it. Take -2, plug it in. 2 times -2 is -4. -4 minus 1 is -5. The absolute value of -5 is 5. So this one also works, and I'm going to circle it. We got two answers. Both answers work, so you circle both. So for this one, what should we do first? So case 1, case 2? Okay, what's case 1? And case 2? I see a lot of people do case 1, they write down case 1, and then they go ahead and solve case 1. Why would I recommend against that? Get both of them down while you're writing this one down. So reason number 1, it's easy to remember what you need to do for case 2 if you write it down right away. Reason number 2, if you don't write this down first, you just write case 1 and then this, and then you solve it. When you get to the end, I see way too many people just circle it and move on, and they completely miss the second half of the problem. There are two parts to this problem. If you forget to do case 2, it's wrong. So we solve. Subtract 2 from both sides. 3x equals 2. So x equals 2/3. Over here, subtract 2 from both sides. 3x equals -6. So x equals -2. All right, check your work. We have 2/3 over here. It's a fraction, but it's not that big a deal. 2/3 times 3 is 2 plus 2 is, absolute value of 4 is, so does this one work? Yes. -2 times 3 is, -6 plus 2 is, -4, absolute value of -4 is, so this one also works. Okay, for the next two problems, I want to point out this important rule right here. The distributive property does not work with absolute value. Do not distribute when you're dealing with absolute value. What do you have to do to these problems before you can split them into case 1 and case 2? What do you mean by do the equation first? We're going to split into case 1 and case 2, but we need to do something to this before we can. Probably want to write that one down. It's all Emma's fault. What do we want to do? You want to isolate the absolute value. I think that's what you guys were saying. This thing right here, the absolute value has to be by itself before you can split into case 1 and case 2. So you're going to work with it just like this is a variable, like if this was a q or something. You're going to try to solve for q. Okay, so solve for the absolute value. That'd be a good thing to write down because I didn't put that up here. And then you can split into case 1 and case 2. So the first thing we're going to do probably is what? Add 1 to both sides. And now I have 3, absolute value, x plus 2 equals 9. Now what? Divide by 3. And what do I get? Absolute value, x plus 2 equals 3. And now this problem looks exactly like this problem. So what could we do? Case 1 and case 2. Okay, case 1 is what? The positive case, so I'm going to write x plus 2 equals 3, and then the other case. All right, so I subtract 2 from both sides, and I get x equals 1. Here I subtract 2 from both sides, and I get x equals -5. Now what? Plug it back in where? To the original equation that you had. You have to go all the way back to the start. X equals 1. 1 plus 2 is 3. The absolute value of 3 is 3. 3 times 3 is 9 times plus -1. 9 minus 1? 8. So this one works. -5 now. -5 plus 2 is -3. The absolute value is 3. 3 times 3 is 9. 9 minus 1 is. So this one also works. Check your answers. We haven't seen one not work yet, but we will. Make sure you check your answers. I'd like you to do this problem. It's very similar to the last one. Let me change colors so we don't get confused. So we subtract 3 from both sides, and we have 2. Absolute value x plus 9 equals 4. Now what? Divide by 2. We're getting the absolute value by itself. So I have absolute value x plus 9 equals 2. Now what? Good. Case 1, case 2. Case 1 is. Case 2 is. Good. Squeeze it in there. Now what? Got to subtract 9 from both sides. X equals negative 7. On this one, subtract 9 from both sides. X equals negative 11. Now what? Okay, we take negative 7, plug it in. What do we get here? 2 times 2 is, plus 3 is, so it works. Circle it. Take negative 11, plug it in. What do we get here? Negative 2, absolute value is 2 times 2 plus 3. Okay, so this one also works. That's how you do these problems. The directions also said graph. So we need to graph these solutions on a number line. The way that you do that is very simple with these equations. If you have just numbers, negative 2 and 3, put your dots. What's in between? Negative 1, 0, 1, 2. That's all you got to do. For the second one, we have a fraction. It's positive 2/3 and negative 2. So let's go negative 2, negative 1, 0, 1, 2 maybe. Negative 2 is going to be right there. Positive 2/3 would be 2/3 of the way between 0 and 1, right there. So I'll put 2/3 above just so that we know that that's what I graphed there. For 1, negative 5, 1 and negative 5, I'm going to have negative 5, negative 4, negative 3, negative 2, negative 1, and I didn't make that nearly long enough. 0, 1, negative 5, 1. And for negative 7, negative 11, start at negative 11, negative 10, negative 9, negative 8, negative 7. For graphing, that's what they're asking you to do. Give me a number line, put a dot on the number line where they're at. The reason it's a dot and not shading here is what? Well, how do we know that? How do we know it's not the numbers in between? It doesn't have an inequality, it's an equal sign. It's an equal sign, so you're just going to have dots. There's no shading. All right, extraneous solution. I already defined it a little bit earlier, but let's go ahead and write it down here. An extraneous solution is what again? A solution that doesn't work. It's a solution that you get. So it is a solution. You found it. But it doesn't work when you substitute it back in. That makes it an extraneous solution. Kind of like an extraneous limb. If you've ever heard of that. Humans have tails. They're extraneous. We don't use them anymore. The appendix is an extraneous organ that will kill you. Whales have legs. Did you know that? They're extraneous limbs. All right, so we're potentially going to have extraneous solutions here. Always check your answers. We might find extraneous solutions on these. So, what's the first thing we should do with the one on the left? What's the first thing we should do as we quest? Case 1, case 2. How come I can go straight to case 1, case 2 here? Absolute value is by itself, that's right. So I can go straight to case 1, case 2. All right, what's case 1? It's a good question. We'll deal with it when we get there. What's case 1? 3x plus 2. All right. And case 2. 3x plus 2 equals the negative version of 4x plus 5. Down the road, you can save some time by just changing all the signs of all the stuff that you see on the right-hand side. For now, this is what we're saying. Kind of like if we had just negative 5 there, or positive 5, we'd switch it to negative 5. Here, we're taking the thing that was positive, and we're changing the sign. That's all that negative means. Change the sign of that stuff. So, solve case 1. We I see that this is going to be positive if I move this over here, so I'm going to subtract 3x from both sides. And rather than drawing my line here, if I'm moving my x over to the right, I'm going to move my number over to the left in the same step. So minus 5, minus 5. I can do all that at once. It saves me time and space. 3x minus 3x is gone. 2 minus 5 is negative 3 equals 4x minus 3x is 1x, or just x. And then the 5 minus 5 is gone. I have my answer sitting right there. X equals negative 3. Case 2, same idea, but now I'm going to have to distribute that negative sign in first. So we have 3x plus 2 equals negative 4x minus 5. And like I said, if you wanted to start with that step, you certainly could do so. All right, this time, my negative x over here will become positive if I move it over there. So I'm going to add 4x here to both sides. And if I move my x to the left, I better move that number to the right, so minus 2, minus 2. 3x plus 4x is 7x. The 2's are gone. Equal sign comes down. The x's are gone here, and then I have negative 5 minus 2 is negative 7. I got one more step, divide both sides by 7, and I get x equals negative 1. So we need to check. Let's take the negative 3 and plug it in. Negative 3 times 3 is negative 9 plus 2 is negative 7. The absolute value of negative 7 is. All right, so I get 7 there. Now I'm going to take negative 3 and plug it in here, and I get negative 12 plus 5 is negative 7. Did I get the same answer on both sides? I got 7 on one side and negative 7 on the other. I took the absolute value on this side. I took the absolute value on this side. I did exactly what the equation told me to do, and I got 7. Over here, I didn't have to take the absolute value, so I didn't. I got negative 7. Are these the same? No. So is this a solution? No. Take negative 1 and plug it in. All the way back to the beginning. Negative 1 times 3 is, negative 3 plus 2 is, negative 1, absolute value of that is. All right, so now I have 1. Take negative 1 and plug it in here. Negative 1 times 4 is, negative 4 plus 5 is 1. Did I get the same answer on both sides? Yes. So therefore, negative 1 is the only solution. The other one did not work. And if you didn't do case 1, case 2, if you just gave me case 1, then you would have given me this answer, and it wouldn't have worked. And your whole problem now is wrong because you didn't even find the solution. If you didn't check to see that this is wrong, the problem is wrong because you didn't give me the correct solutions. So you have to check these problems. It does say graph, so let's throw a number line down on here. The only one that works is negative 1. So I'm just going to go negative 2, negative 1, 0, and put my dot right there, and I'm done. Go ahead and do the second one. So what's our first move for the second one? Case 1 and case 2. The absolute value is by itself already, so we're ready to go. Case 1, case 2. What's case 1? Everything is the same, you just don't have the absolute value symbols anymore. And case 2? Okay, perfect. We changed the sign of the other stuff on the other side. Solving case 1, I see that if I move this over here, my x's will remain positive, so minus 5x to both sides. And I'm also going to, if I move my x over here, I got to move my number over there, so I'm going to subtract 14 from both sides at the same time. This is gone, this becomes negative 16 equals 2x. Divide both sides by 2, negative 8 equals x. Did I do my math right there? Everybody got negative 8? Yeah? All right. Case 2, what should I do? Add 7x to both sides, which means I should also add 2 to both sides, because I'm going to move that number over there. Draw my line. What do I get here? Negative 12. Divide both sides by 12, and we get x equals -1. Now what? Check. -8 times 5. -40 minus 2. -42, absolute value is, all right, we got 42 on the left. -8 times, am I going to get a positive here? This one doesn't work. Case 2, -1 times 5 minus 2. Absolute value is +7. -1 times 7 is, -7 plus 14 is, so does -1 work? Yes, -1 is the only solution. And again, if we draw a number line, it's the exact same number line. -2, -1, 0, put my dot there, and I'm done.